We started to study Bayes' rule because we wanted to understand information cascades. We wanted to understand how it's possible that in a setup where people sequentially make decisions, they can get the decisions so wrong, despite collectively having a lot of evidence to what might have been the right decision. Recall the experiment we were thinking about. There are two urns. One is majority blue, the other one is majority red, and they were equally likely to be selected, and then people were pulling balls from these bins, and they wanted to guess what the majority color of the urn that they're using. So for the first person, we computed the probability. If he pulls a blue ball, then the probability that it must have come from a majority blue urn was 2/3. So a rational first person should guess blue color if he sees a blue ball is being pulled. And so far, this was all simple. But now we want to think about the sequential decision making. So after this first person guessed the blue color, remember the setup is that the second person hears the guess but cannot see the blue color. This doesn't seem to be a problem here because, as we just computed, a blue color guess, you can infer that the person must have seen a blue ball. So now let's think about what the second person does. So let's say if she pulls a blue ball, then life is easy. She can infer that the first person must have pulled a blue ball also. So far, 2 blue balls have been pulled out of this bin. That would make it even more certain that it must have been a majority blue urn. And in fact, you can work out the probability at this point. It's 80% likely that it must have come from a majority blue urn. So again, the second person should guess blue. What would happen if she actually pulls a red ball? So she sees her own red ball that she just pulled. She can infer that the first person must have pulled a blue ball. So at this point, 2 balls came out of this urn. The first one was blue and the second one was red. Let's assume that this person trusts her own ball a bit more than it trusts the other one, and so maybe we'll guess that it must have been a majority red urn. So far, life is nice. The first 2 people, they guess, betrays what kind of balls they've seen. So we can infer the color of the ball even though we haven't actually seen them. If they guess majority blue, they must have seen a blue ball. If they guess majority red, they must have seen a red ball. Something very different can happen with the third person, especially if the first 2 colors were the same. Let's say the first 2 people pulled blue balls, both of them. The third person, if he also pulls a blue ball, then life is simple. He can infer the first 2 balls were blue, and his ball is blue. That's a total of 3 blue balls. At this point, really strong evidence that it's a majority blue bin. However, what happens if his ball is red? So he sees a red ball, but he can infer that the first 2 people pulled blue balls. So at this point, he knows about 3 balls that came out of this bin, 2 blue and 1 red. And in fact, now it's more likely that the bin is majority blue. Again, we can work it out using Bayes' rule. It comes out to be a probability 2/3 that this is a majority blue bin. So a rational third person, despite seeing the red color, should guess blue. Should do this because that is more likely than a majority blue bin is more likely than a majority red bin. This is what we call information cascade. The third person, despite having some evidence about the red color, rationally should actually make a decision that goes with the first 2 people, following the advice of the first 2 people, is selecting blue as his guess. So far, nothing very odd happened, because indeed, we correctly worked out the probability, and the third person is rationally following the first 2 people. Of course, this can easily be wrong. 2 blue balls can come out of a majority red urn. This has probability 1/9, 1/3 for each of the 2 balls. What's surprising here is that if we continue the experiment, the same situation will apply to every future person. Not only the third person, but the 8th or 9th or 100th person will also be exactly aware of only 3 balls, the first 2 and his or her own. Remember, we no longer can infer the color from these people's guess. And from then on, they all should make the same guess blue, no matter how many red balls gets pulled from the bin. This unfortunate information cascade, or wrong information cascade, can happen not only if unlike the event that the first 2 balls were blue, but can actually even happen later. The first 2 draws, a first couple of draws might alternate color, and at that point we can keep inferring the color of the ball from the guess the person makes. But with a couple of identical colors coming in a row, the majority is not determined, and from then on, this information cascade starts, and further people should infer the majority color, ignoring their own signal or their own color of their own ball, and trust the crowd. So this phenomenon is called information cascade, and what we're trying to understand using Bayes' rule, that it has a, unfortunately, large size probability of getting the result actually wrong.